Hello, everyone, and thank you for joining this episode of the Data Byte session on the topic of future factories. I think that today's topic is really very interesting because it's a topic that is pretty much neglected sometimes, especially in the past years where I was in touch with factory owners and manufacturing companies. I saw that not many of them are actually thinking about kind of the intersection between the factory building and the production that is in there. Now we see a rising interest among the production companies because they are thinking about sustainability, efficiency, and they look for new ways of increasing the sustainability and efficiency of their factories. And now they are really starting to think about what is actually happening with the building in which I have my production. And I'm very happy to introduce an expert on this field and our today's speaker, which is Julia Reisinger. She's an assistant professor for industrial building at the Institute of Building and Industrial Construction at the Technical University of Vienna. And in her work, she aims to harmonize the industrial building and production planning processes with energy efficiency and sustainable aspects. So she really works on the intersection between the actual construction of the building and then the production side, which is in the building, in the factory. Thank you so much for joining us, Julia, and I'm really looking forward to your presentation. And I hope all of our guests will enjoy this presentation. For those who could not arrive, or for those who want to share it with another friends of them or colleagues, the presentation will be sent to our participants per email, and the recording of this webinar will be online on YouTube. So, Julia, thank you so much for coming, and the floor is yours.
Thank you, David. Thank you for the invitation. I'm gonna share my screen. You see like my whole screen now?
Yes, everything works fine.
Okay.
So you're set to go.
So thanks again for the invitation. I'm talking about future-proof factories today and how to digitally integrate industrial building and production planning processes for resource-efficient factories. David already introduced me very shortly, so maybe I skipped this. So I did my doctorate in civil and environmental engineering. In industry, I was working mainly on project management and structural design. And since this year, beginning of this year, I have the tenure track position for industrial building at TU Wien. And besides that, we are spinning out some developments of TU Wien, which I'm going to present today. And I'm the co-founder of the spin-off Factory Maker. So my main topics are in integrated industrial construction and industrial building design, in BIM-based design, building information modeling, and also how can I support production and building planning with computational design to simulation, optimization, and prediction. And with always the focus on sustainable construction and life cycle assessment. So just a short introduction how our institute is arranged and is working. So I'm from the Institute for Building and Industrial Construction, and we have three research departments: integrated planning and industrial buildings, where I come from, then building construction and building preservation, and integral building technology. The head of the institute is Ivo Kovacic, and actually like the main focus of the whole institute is like to integrate different disciplines and have a holistic view on building design. So the research department, integrated planning and industrial building, we really focus on how can we integrate production-related parameters, disciplines, simulations with building simulations, because they influence each other. We had multiple different research projects, so I'm just showing here three. Info, where we did interdisciplinary research on energy optimization in manufacturing companies. balanced manufacturing with simulation and ICT to resource efficient production, and BiM Flexi, which I'm going to talk about today, the digital platform for design and optimization of flexible buildings for Industry 4.0. And what we mainly do is like, you have like these multiple layers. You have the location of the property and the location of the production. You have the building and the energy systems. You have the production line and you have the machines. And what you actually need to do is like when you plan one of them, consider all the other fields as well. And how I did that in BiM Flexi, I'm going to show you now. So just a little bit to wrap it up, why we are doing what we are doing. So everyone knows we have this energy and resource scarcity, and there is a really big pressure on industrial companies to get more sustainable, to reduce their environmental impacts. And what is really relevant is that we need to reduce our resource demand. And actually the industrial sector is like consuming a lot of energy and resources. And now to go a little bit back, like within the years, we had this key innovation, and with the contractive cycles, the waves of innovation, you can see like key innovations always initiate new industrial and social development stages. So now we are like in the life science, solar technology. Beforehand, we had the internet, mobile communication stage. And why I'm telling you that? These innovation cycles also have a real big impact on the product, on the process inside the building. Like the process and the product always adapt according to the innovation cycles, according to new technologies, according to the increasing customer demand. And they're quite flexible, let's say it like that. The product is very flexible. The process can be adapted a little bit more easy, and also the lifetime is not that long, but now you have the building around it, and the building has a very long life cycle. You once build it, it's very rigid, it's there, and you have to deal with this building and this enclosure system you're building around. So, but now when processes and products change, maybe the building is in the way, maybe a column is in the way, maybe you need more height. And so we need flexible building structures in order to increase sustainability, because if you have to demolish the building, if you have to rearrange things inside the building, it's always related to a very huge resource demand. But it's quite interdisciplinary, and we need like integrated industrial building design. So when I want to design a very flexible building, I really need to know what is going on inside the building and also see future scenarios for that. So, and here already the first problem starts. If we talk about integrated design, we have multiple disciplines and everyone is working in different fields with different simulations and looks at different parameters. So when production planning, manufacturing planners talk about the factory, they see the workforce and the resources and the material flow inside the building, or the input and the output. This is what most of the participants of today probably are planning. When we are talking about the factory in industrial building design, the factory is for us the construction, the building enclosure, the HVAC, like heating, ventilation, and the energy system. And we are going to take into account the inside steps, the media flow, the people flow, the material flow, and the whole flow through the building. These are all constraints and input criteria for us for our design. And so when we think about that, we have like a lot of interdependencies in industrial building construction, which comes along with a rising and high complexity in industry. So here we tried to summarize in a diagram in the graph data model, okay, which elements, which parameters are influencing each other with different fields. And also if you talk about industrial building design, you just have not just one building designer. You have an engineer and civil engineer who does the structural design. You have an architect who does the design of the geometry and the facade systems. You have the building service equipment. and you have the production planner and the production lines. So these are all interconnected and they're all influencing each other. And what is now the problem? So currently we have a lack of integration and interoperability. So stakeholders work together, but most of the software tools and models and simulation models are not integratable, or there is no interoperability between them. Then we have still a sequential planning process. So once the manufacturing planning is done, it goes to the architect. Once the architect draws one building, designs one variant, he gives it to the structural engineer to calculate it. So it's very sequential, and then flexibility is rarely considered in architectural engineering design of factories. So when you think about designing a factory and sustainability assessment methods, it's not the first thing that you talk about flexibility. And I already mentioned it a little bit. So you have time constraints in planning processes, and this complexity often forces the stakeholders to select and investigate one option. And so we are overlooking opportunities. And also, like this one option you're designing, constructing, is very labor intensive, and it's a manual planning process, right? So, but if you take into account the whole complexity and all the parameters which are happening in such interdisciplinary environments, we have an exponential growth in planning variance. The more planning parameters or the more disciplines are joining or are needing to be considered. And finally, the most important thing is, at the very beginning of the early design stage, you have the possibility to influence impacts and costs. But it's like in the very early planning stage, where like the planning costs of a whole building, this is a graphic from a building, the planning costs are only 3%, but within this 3% of costs, you have the biggest impact on the performance of the building during the whole life cycle, right? So we need to integrate all disciplines and all disciplines knowledge at the very early start of a project to be able to consider life cycle performance and enable sustainable construction. So now I'm coming to the BiM Flexi project. It was a funded research project supported by FFG. And in BiM Flexi, first of all, the aim was to develop a digital platform for integrated industrial building design, meaning addressing the beforehand described topics: integration, prediction, and optimization of production planning and building design. And an underlying method we've developed was the integrated production cubes concept, which I'm going to talk about a little bit later. Then the second goal was to coherently optimize the building and production layouts, simultaneously calculating the load-bearing structure, because the load-bearing structure of a building is the most rigid one, and it's the most resource-demanding one. And if we have flexible layouts, we need to have an optimized load-bearing structure. So the goal is to identify the most flexible and resource-efficient building option. And finally, to incorporate feedback mechanisms at early design stage, that you really have fundamental decision support, meaning our tool, our platform should give real-time performance feedback to the lifecycle costs, to the lifecycle assessment, and the flexibility of the structure and the layout. And for that, we've also developed a novel interdisciplinary collaboration tool for multiple users, like interdisciplinary planning teams in virtual reality. So the platform, first of all, the goal is to couple production and building design. So how can we couple production and building design at early design stage when nothing is set, right? Then we want to enable an automated variant generation of production layouts and the building grid, the building design around it. They should automatically generate themselves and optimize them together, like in an integrated way. And finally, All the variants which we are investigating should give feedback to the flexibility performance, to the cost performance, and the environmental impacts. This is just a short overview, rough overview of the platform. I won't go too much into detail, but this system enabled us to integrate, simulate, and optimize both planning fields at early design stage. So we have a production layout model, a parametric production layout model, and a parametric building model with evolutionary algorithms, with multi-objective optimization, which automate the process. They are coupled together. So we found a system for coupling, which I'm going to present in the next steps. Then besides that, we have the multi-user virtual reality support and the results feedback with flexibility and LCA performance feedback. And what we realized, like the tools planners are using nowadays, like production layout planners like Vistable or architects with BiM, Revit, these are not for early design stage and very flexible design options. So we realized we need to provide a model which generates, optimizes building and production designs, but which are exportable or integratable then into later post-processing steps like BIM, finite element modeling, and real layout planning. So this is the system we've developed. It's the design space for integrated industrial building design. So we found a parametric structure which describes a structural system grid for flexible industrial building structures in X, Y, and Z axis. And also we've defined different structural element types in industrial building design, exactly for the design space. And then we've, in kind of a way, we've introduced production cubes. So we said, okay, we can't model like every small machine and every interdependency, but we can think of cubes. So you have these production areas. One production cube is storage, one production cube is milling, and there the smaller processes are already involved and incorporated. So each sub-process is one production cube, but also these production cubes have the relation to the structure and are described by geometric constraints and load inputs for the building topology. And first of all, I'm going to present the first tool which was developed, the automated production layout generation and optimization. This one is based on this parametric description of production cubes and the layout, and it provides multi-objective optimization of production layouts within an evolutionary algorithm and generative design. And the optimization behind it, that multiple variants of a production layout are generated. They also consider production, building, and flexibility criteria. So we introduced new objectives into production layout planning. And finally, the tool also enables that it gives quantitative decision support. So it doesn't just generate you the layouts and you can pick from one, but it has some quantitative feedback. So you can really select these production scenarios for the building design, which are according to your needs and which you want to integrate into the building design. This integrated production cubes concept, just here a little overview. I don't go too much into detail. So we have these cubes, but these cubes also contain the building and flexibility information. And what the designer or the planner or the building owner needs to do is just to give some input, like the algorithm needs some input. So the input is process requirements, some minimum cube dimensions. Okay, what's the minimum room demand I need for producing my goods in this area or for storage? And also, like, if I have machines, if I have other technical equipment, what are the loads? So I can already input some load knowledge I know, which are then considered in the optimization. Then media supply information, and of course, the location, the property, what are the outer boundaries for layout production. And then you let the multi-objective optimization algorithm run. And what you get is an optimized process. So the cubes are allocated according to your requirements. You get optimized cube dimensions. still the associated loads and media supply per cubes are stored, saved, and you get a proper location on the property. And there's like multiple designs. And here you see on the right, it's like a graphic where how this parametric design looks like. So you can now click with the slider for different variants and investigate them. And the objectives we've integrated is like we had flexibility objectives, because the main research goal was like, okay, how can we measure flexibility? So it's like the available building space must be, how do you say? So the cubes must be placed that the building space is properly used. It should, the layout density should be maximized, and the ratio of cube dimensions should be according to the input. And the productivity objectives were the lean factor matrix. So that's the input and the goal. So the input of the designer is he decides which cube has to be together, which cubes are not allowed to be together, which should be maybe close to each other, and you have the transport intensity metrics. And according to that, the layouts get generated and optimized. So we've tested this production layout generation model on multiple test cases. And what we saw is, and the feedback from the expert we got, is like, it's a very simple input scheme. So it generates very feasible two-dimensional production layouts, where I have to say it's in the ideal layout planning phase. So afterwards, for the real layout planning phase, you're exported into your proper tool and do some fine-tuning. Yeah, exactly, that's what I just said. So we have well-approximated layout scenarios at ideal planning phase, and it gives a sufficient geometrical description and the spatial arrangement of production sub-processes. Also, our algorithm succeeded to produce cohesive layouts which do not exceed outer building limits. And it was very beneficial for the users that we provide this layout visualization with quantitative objective assessment, and which supports the decision making. But now the integration. So we have this new parametric production layout generator, but now we haven't designed the building, right? So we needed to investigate the dependencies to the building, and we've designed a model which couples the production and the building model, which considers the selected layout. So after layout selection, I can integrate them in the building design model. And finally, we integrated methods for the performance assessment. So the life cycle costs get calculated. The life cycle assessment, meaning greenhouse gas potential, primary energy demand, the recycling rate is calculated, and finally, we get flexibility feedback. And what means flexibility feedback? So we also had to introduce new flexibility matrices, because they're not available right now, especially not for industrial building design. So what means flexible industrial building in terms of changing production layouts? It's first the retrofitability of the structures. So you apply and maximize the retrofitting load, so you have some reserve for future changes already planned beforehand. You provide some expandability of the production layout, so you want to maximize the free area of the production, that you can do some extension in future. You want to have some flexibility in space, so you maximize delta H, delta height, and you have flexibility in floor plan, meaning the algorithm should find designs which have like not so many columns in the middle of the hall, right? So that you can move freely inside the building. And these formulations work with the building system grid and the production cubes definition. And now, finally, I'm going to present you the final algorithm, the optimization and decision support tool for future-proof factories. So we integrated the production layout model into a special building design model. So now you can do both simulations together. It enables the automated generation and exploration of building alternatives. It provides automated structural analysis and the element dimensioning of the structural types and the columns and the girders. And it gives feedback of each generated variant to, as said, flexibility, environmental impact, and cost impact. So we can do now layout studies with the axis grid. The axis grid is very flexible. We can change different materials, investigate different materials and structural types. So the algorithm investigates timber, concrete, and steel construction. And it also changes and investigates different building envelopes and different roof assemblies. So do I have some photovoltaic systems on the roof? Do I have a green roof? You can do variant studies and investigate the whole design space. And then it gives you design options with quantitative performance feedback. And now I talked a lot theoretically, and I'm going to show you now a short demonstration video. So here is the ideal layout planning algorithm. Like the layouts were already generated beforehand. Now you can click through, and then you can decide which layouts you want to integrate in the investigation, just 1 or 3 variants. Let's see what's the perfect match. And then the building planning and optimization. You start the optimization, you don't need to do anything. And now the whole design place gets searched by the algorithm. And it generates and optimizes all different variants, collects all the data, and now gives you the feedback. And you can click through the different possible designs and make some transparent decision making, right? So you can also go through it with your interdisciplinary team and make proper decisions. So you have the 3D model generation, you have the visualization, you have the ranking of the performance of different variants, and the real-time performance feedback to 11 different objectives. And you have some preference weighting, maybe only the costs are relevant for you. So you can say, okay, I'm only interested in the most cost-efficient options, so please just show me the most cost-efficient options. Yeah, and we have some database analysis available. So also it just doesn't produce you the designs and the 3D models, but afterwards you can do really some parameter-based variant studies and results analysis and do quantitative decision making. That's to support the decision-making process. We thought, okay, let's try to incorporate virtual reality in the process and into the system, and maybe it helps to improve the decision-making in interdisciplinary teams. So this multi-user virtual reality framework was developed, and we've integrated or coupled the whole simulation and optimization system into virtual reality. And you can do very flexible industrial building design studies now in VR, communicating with your team colleagues. And here I have a short video. So the building gets generated, the first version. Here on the right, you have feedback. In the front, you have a small table, and you can look at the different production scenarios. Okay, they want to go to the production manufacturing area now. The third one has to agree that he also wants to go there. And then they get zoomed in. What we didn't do here in the video, we don't have the machines inside yet. So you could place the machine and the production line as well. But now you're like in this cube and you see the different columns. You can see the objective weighting and then look at different designs. So this is the VR framework we've tested and developed. Exactly. So we've validated the whole process and the tools as well. So we did a comprehensive user study with 40 industry experts from architecture, civil engineering, and production planning. We've tested it with 50 students and already did 10 pilot projects with companies on real projects from production planning, industrial building design, and with a huge construction company from Austria. Evaluating the tool. So what was the feedback from the market? So the tool efficiently supports the building owners and industrial companies management in making priority decisions already in preliminary design planning. And it helps to anticipate and facilitate subsequent planning steps and rescheduling by finding a good option according to all needs very early. And the software use reduced the planning time of building planners and production planners by 90%, and found variants that saved 20% of costs. Besides that, also the algorithm found variants that saved 30% of CO2 emissions in accordance to what the companies would have planned otherwise. Conclusion, I'm already coming to an end. So each development, is it the building generator, the layout generator, or the multi-user VR system, shows important developments in their respective area. And this parametric integration approach we've developed enables now coherent investigation and optimization of both systems at the same time towards more flexible systems. Furthermore, it provides the design teams with a better understanding of the environmental and economic impact of their design decisions. And the pilot projects demonstrate very promising real-world application results. So to use the tool, it's best suited for facilities with every production and logistic type with a moderate system complexity, for fast-growing and expanding companies, and for sustainability conscious decision makers. And what the important advantages are is it raises awareness of the importance of flexibility and life cycle-oriented building and thinking. And it breaks up silo thinking between disciplines and reduces manual iteration steps. And you have a very simple model installation and very simple model use. So, of course, there are future outlooks, and we haven't explored so far now the energy efficiency aspect. So we were always talking about resource efficiency, minimizing the resource demand, but energy efficiency has to be incorporated like in the next steps, which is according to due to the parametric approach, quite feasible and possible. So also we've produced only horizontal production lines and one floor buildings. So in future, we need to investigate or develop it further to vertical production, and also look how it is with existing buildings, like how can I incorporate new production line in existing buildings. And of course, the whole parametric approach is adaptable for office buildings. And this is the spin-off from the BiM Flexi project. So we are currently in the funding and founding process, Factory Maker. And if you have like real product pilot projects, if you're interested in the tool, if you're interested in corporations, reach out to us. We would be happy to answer your questions and work with you. But also now I'm at the end of my talk, and I'm happy to answer your questions now. Thank you.
Thank you so much, Julia. That was really a great presentation. And I see that you're working in the field of efficiency, because you were quite quick, but I think you explained everything really well. Still, I would like to invite all of our participants to either raise their hand or ask a question in the Q&A box. But I have my first question to you, because actually when I was preparing yesterday, then I had a short meeting with my previous study colleagues, and they're all working in like manufacturing companies. And as usual, the people from production, they are sometimes quite skeptical when it comes into new technologies. And they were like, we have all these brownfield factories, and we are not really able to change anything in there. We have to work with the space we have to work with the people we have in and with the machines. So is the tool actually applicable for brownfield factories, so the ones that are already standing and which have to be modified to have a better or bigger output or be more efficient?
Yeah. What I presented now was, of course, for new construction projects. It is adaptable to existing building structure. What is really relevant for this case is that you have to have a proper documentation of the existing building structure. So that's another kind of field. Do I have a good planning documentation? Do I need to scan the building? Like, I really need to digitize the whole existing building into my digital model. So if I have a proper digital model with proper information, which is mostly the most complicated part, then it's possible to use it also for existing buildings, yes, and adapt it.
Great. I will inform them then. Another question I have is like the AI system itself. It looks like you need a lot of training data and you need a lot of informations about the company and a lot of use cases. So how did that work out? Because usually the training data is a big issue while like generating AI models and AI tools. How was it in your case?
The good part about this parametric generative design approach we chose, it's not based on training data. We don't need training data. Our algorithm produces and generates every building system according to our description and the parameters. So we don't have any training data. But what is like very efficient now and why we can use this model now in future for more improved designs is we have a generator which generates thousands of variants within, let's say, 1 hour, right? Like 10,000 of variants. And we can use this data now as training data to improve the algorithm. But so far, we don't work with training data.
I see.
It's this generative design approach.
Cool. So I see no questions at all. If somebody wants to raise a question, then now it's the time to do it. Otherwise, we will also. Oh, there is one question. Thanks for the presentation. Could you suggest as to what is the roadmap for greenfield manufacture? What is time frame and resources need for this process? So probably how much time and resources do a company need for like to set up a greenfield manufacturer with this tool? I think the assumption is probably that it takes more time to do it in an optimal way with your tool than if you do it without it.
So if I get the question right, so we've tested it with planning offices, right, on real projects. And we know that for the first variant, for the first design, until they received the production plan, they design one variant, to do the structural analysis. There are like multiple disciplines involved, and until like everyone is done, you have like a time frame from like 4 weeks to 1.5, 2 months until you have like one variant, maybe 2 variants. And our algorithm now with the whole input we get from multiple disciplines, so we need to go there, we need to have some demand planning, ask the different experts what are their preferences, what do they need. And once we've run the algorithm, we provide the whole design space within hours. And the advantage now is they can decide on the best option, like after a few hours, and then go on with the detailed planning. So they can immediately start with the detailed planning and don't spend like 4 to 2 months time in demand planning and variant planning.
I see. So it saves a lot of time in the preparation phase, kind of, and in the design phase.
Exactly. It saves a lot of time and it gives you more transparent decision making. Because often you oversee maybe a good design because you just don't explore it, right?
Cool. Then I think that's a good closing for us. I wanted just to say that I'm really happy oh, there's another question. How do you see the potential of VR and AR in designing and operating sustainable oriented factories? Because I think you presented already that you use this VR model for the presentation of the factory. So what are the benefits and what is the potential of it?
I think, yeah, the benefits are that you can maybe the thing is, you have to decide, like a building owner or a production company, a manager of a production company. For him, it's very beneficial because he has more realistic imagination of the to be in future planned building or production process, so he can really see what will be going on. Like it's this real world experience. So for him it's beneficial for some visualization, right? And there's like the last step of the decision-making process. But we saw when we've tested it also with different planners, with production planners and architects, for them, the VR system itself, it was like a nice game and it was like fun to be in the environment for half an hour, but it didn't really give them any benefit according to the desktop-based version. So the planners still, the disciplines who are working on the projects, who have already, like when they see a 2D plan, they can imagine how it looks like because it's their knowledge, right? They don't need the VR application. It was too complicated for them to really design. But maybe for the production owners, for the managers, it's very a nice extra advertisement tool, let's say it like that.
I see.
And augmented reality, augmented reality is cooperating with the real world, right? So augmented reality will be in future very relevant or very interesting for existing building structures. So you have an existing structure, you have an existing production line, and you go there with your AR system and visualize the future steps, the new planning in the existing building. So this is for AR, but for the very early design stage, AR is, I would say, not very interesting.
Okay, so basically it's something which also makes the decision easier for the decision makers at the end, because they are usually not technicians, or some of them are not technicians, so you can really represent what the outcome will be after the factory is being built.
Exactly.
It's really also great from my perspective that you are spinning this technology out and that you're starting your own company or a spin-off of the Technical University of Vienna. We have many students in our webinars usually that are actually aiming also to search for new business models and to kind of transform the prototypes that they develop in the duration of their studies, PhD or master studies. So what is the biggest hurdle for you right now to create your company and to kind of to start a startup?
I think it's for everyone something different, right? It depends on from which area you're coming, which are your interests. And for us, it was like we've developed this technology like within a research project. It was research, and now you have like a real working prototype. And for me, the biggest hurdle was like to learn all these management tools, how to start a company, the economic parts of starting a company. So from the technical part, so if you're a technician, it's probably very easy to work on the solution and on the technology. But besides that, you really need to think about the market. What does the market really need? Talk with potential customers, and not just start creating and building products without talking with the market.
I see. So you have to learn a lot of new things, and maybe find also new people that you hire, because you need this know-how which you usually don't have in that
exactly
much like yeah.
The team is very important, and within the team it's very important that you have like a very interdisciplinary team and everyone brings something extra to the table.
Right, but it's really always cool to see TU Wien spin-offs, because it's my alma mater kind of, so I'm it's really inspiring, and I hope that there will be more in the future. There is another question regarding the technology, which is what part of the solution can be dynamically developing beyond the first assessment decision making? I'm not sure if I understand it correctly.
I think I don't see the question. Maybe when I read it, I understand it.
If you click on the Q&A, you see it in the button. What part of the solution can be dynamically developing beyond the first assessment? Maybe if the visitor could raise his hand and explain what actually the question is about. or maybe some explanation into the chat.
What part of the solution?
I have another question in the chat that is, can you already tell something about the business model? Do you plan to sell, license the software, or provide engineering services? So that's quite an easy one.
Okay, yeah, so we don't sell the software, so we will it will be a software as a service solution. So we are also not licensing the software, so we provide it on a software as a service cloud platform, and it's the real how do you say it? Like, I'm missing the word right now. The real payment solution. We haven't found out right now the proper solution, so we're talking with the market what is more convenient. Maybe it's pay-per-use, maybe it's also a monthly subscription, but it will be a cloud-based software as a service solution, and no selling and no licensing.
So your customer will be the factory owner, or will it be the one who is planning the factory?
Both, actually. That's very interesting. Like, both fields were very interested in it, because for the manufacturing planners, it was very interesting that they have now, for the first time, a tool that they can also estimate the building and the building costs and the building variance around their planned layouts, because it's also possible that you can just integrate already planned layouts, and just around this one layout you let few variants generate. And so they see it also as a marketing selling strategy according to their business owners, or to their Auftraggeber. And the civil engineers and the architects, they profit from the fast generation of variants without needing to design it, to model it, to calculate it. And so it's both.
Very cool. So thanks to the visitors for the great questions and interesting questions. Thank you, Julia. Thank you so much. We wish you luck and many interested investors for the future for your spin-off.
Thank you.
And yeah, so have a nice day and join us in the next Data Byte session.
Thank you. Have a nice day too.
Bye.
Bye.